Hello, in this video I'm going to show you how to make a little vampire which is going to keep your plants from getting dry while you're away. You don't need to build it into a vampire, but this is the only case that I had lying around. I had these little DC pump motors lying around from a previous project when they were actually immersed in photographic chemicals. I wouldn't recommend reusing anything that you put in photographic stuff, but I gave them a wash in plenty of hot soapy water. I still wouldn't drink anything that had been through them, but they're probably fine. But the leads had been corroded because they'd been lying around for years without having been properly dried off or anything. So first I had to repair the leads. So I've just finished soldering the pump motors onto longer wires. This is obviously repaired these kind of badly corroded wires that they were attached to, and also lengthened them, because what I'm intending to do is drop these down into 5-litre bottles, like one 5-litre bottle for each of these pumps. So that means I get 10 litres of water reservoir, which is probably enough for 3 days away. Anyway, to simplify the wiring, I wired both negatives of the pumps to a single connection here, and just separated out the positives, so it's going to make it simpler to attach this whole thing to the breadboard. So I'm just going to build one of the moisture sensors. My idea is to have one moisture sensor per pump, and I found this quite useful bent set of header pins. All the moisture sensor is doing is measuring the resistance of the soil, and so you need basically just 2 contacts separated by an insulator. So this is perfect, and of course you want the contacts to be held a uniform distance apart, so that you can so you're always measuring against a known quantity. So what I'm going to do is solder this just normal mains cable. I tend to use mains cable a lot because obviously you don't really need something as thick as this, but over a longer distance the drop in current, that is the resistance of the wire, is very, very little because of the thick wires. It's durable and it's cheap, so yeah, that's just my preference. So what I'm going to do is split this out and solder one of these wires to that end, and the other wire to this end of the connector. That's all the moisture sensor consists of, really. The magic happens on the Arduino board itself when you just set up a voltage divider with a very high resistance, that is about 1 meg, to compare the soil resistance to. I'll go over that a bit more detail later. I just finished soldering on the that curved header connector on that end of the moisture sensor, and just connected it to jumper leads on the other end to make it easier to connect to the Arduino. I heat shrank the solder onto the end of those jumpers, but this should just give the whole joint a bit of extra strength. So I've just connected the Arduino to the computer and plugged in the moisture sensor that I just soldered up. So this is a breadboard layout for a single moisture sensor and a single pump. The pump is just an electric motor with a particular housing around it, so that's why I've represented it as a motor. But so on the part of the video that you were just watching was to do with the moisture sensor, so I'll talk about that. I've represented it just with a pair of wires leading off the board, because it's not really a component, it's literally you're just sticking 2 bare wires into the soil. Maybe I'll just start from the power source though. This is going to be about 6 or 7 volts coming in from a small power adapter I found, going into a voltage regulator, a 5-volt voltage regulator. All the grounds are connected together, so 6-7 volts comes into the voltage regulator, comes out as 5 volts. So these rails along the side of the board have 5 volts here and ground here. So this is just supplying power to the Arduino. 5 volts into VCC pin and ground into the ground pin here. So that was the power part of the circuit. The moisture sensor is connected first to 5 volts through a 10k resistor that goes out to one of the wires of the moisture sensor. The other wire of the moisture sensor is connected to ground through a 1 meg resistor, and that same rail here is connected to the analog 0 pin of the Arduino. So essentially what it is a voltage divider with a very high resistance here, 1 meg, because obviously you're measuring a very high resistance. Even soil with water in it would have far higher resistance than any normal electrical component. And this is just a current limiting resistor going into the top of the voltage divider. That will reduce the range of voltages that you're measuring across. This is an Arduino Pro Mini. It's one of the cheapest versions of the Arduino around because it comes without a USB kind of section on it. So you need to connect it to the computer via a FTDI USB board, which is connected to these pins here in the video. I'm just going to use a very basic program which actually comes as an example on the Arduino environment to test the sort of readings I'm going to get from a pot of soil. So I'm just watching the Arduino serial monitor here. All it's doing is printing out the sensor reading to the screen. And all this sensor is doing, as I said, is measuring the resistance of the soil. The resistance goes down the wetter the soil is. So this is actually a very sensitive sensor. Even touching the sensor produces a very noticeable measurement. That's measuring the resistance across my skin. This is probably very similar to a lie detector. The more that I'm sweating, the less resistance my skin will have. But I'm not going to do a lie detection test right now. I've got a pot of soil. This is dry soil. You can see there's very little difference in the readings on the screen from when the sensor was just in the open air. So the dry soil has a very high resistance. When I put the sensor into wet soil, the reading goes up to something around 600, 700 even. Take it out, put it in. Take it out, put it in. And then, just clean that off there a bit. I put it into the dry soil. You can see there's very little difference in the sensor reading, whether it's in the dry soil or if it's in the open air. That's the wet soil again for comparison. Oh, up to 800 even there. So that's quite a big range across which to make measurements, so it should be pretty easy to choose a threshold just below the maximum reading, and that should be very reliable signal to trigger the pump to send more water out to the soil. So now I've calibrated the sensors, I'm going to think about how to connect the pump motor. The motor is connected to the Arduino via this N-channel MOSFET. This is basically an N-channel transistor which can switch very large loads. This pin here is called the gate. That's connected to the digital pin on the Arduino through a 10k resistor, just a current limiting resistor. So that's what turns the transistor on or off via the digital pin. This pin here is called drain. This is what you connect the actual load to. So the load, one pin of the motor is connected to the full voltage coming in via the by the power adapter, which is probably 6 or 7 volts. The other pin's connected to the drain, and the final pin of the MOSFET is called source. It's connected to ground. So when the transistor's turned on, the current can run through the motor from positive via the transistor to ground. I found a box to put the circuit in. I need to make a few holes in it for the wires, so I'm going to use these grommets. I'm going to make a hole large enough to fit these grommets, which looks to be about 12mm inside the groove. I'm going to make 2 holes, I'm going to make 3 holes, one for the motor wire, another for the sensor wires, because you want to keep those separate, because the motors can actually interfere with the sensors by inducing a current in the sensor wires. When the sensor is as sensitive as a moisture sensor, then that's a lot more likely to happen. I'm also going to have to drill one more hole for the power supply wire, and I decided to also drill holes for the eyes and put in some red LEDs just for the hell of it, and those can double for indicators, for instance, whether the sensor has been triggered or not, because I think I need to introduce a delay between when the sensor is triggered and when the motor turns on. That is, that the motor won't be directly controlled by the sensor. It may be the motor will turn on for a few seconds. That is, the motor maybe will turn on for a few seconds and then turn off, regardless of if the sensor is still triggered, because there will be some sort of latency in the system. That is, there will be a delay between when the motor starts pumping and when the moisture seeps through all the soil to a point when the sensor is triggered, and you have to account for that. Otherwise, the motors will turn on, wet the soil far too much before they turn off. And that was a very long-winded explanation for why I'm going to put LEDs in the eyes, because that's going to tell me when the sensors are triggered, regardless of if the motors are turned on, because it won't necessarily work that the motors are always on when the sensors are triggered. I'm going to start with the eye holes. The LEDs are 3mm exactly, so I'm going to try for a friction fit. I should probably centre punch these first, and the block of wood is just to stop the metal bending inwards and hopefully make a clean edge. Just centre punching the eyes with a screw. I know this isn't really how you're supposed to do it, but it works. Kind of looks like a steak, doesn't it? But, you know, I'm not going to ruin the box. Looks like a nice clean hole. Just going to see how one of these LEDs fits. These are clear LEDs, so it's pretty useful to write what colour they are on the back, because there's no way you can tell otherwise other than actually powering them up. Okay, I can feel that's going to be a tight fit in there. Quickly clean up the holes on the other side. Should make it easy to get the LED in. I had to push these in pretty hard. That's kind of what I wanted. I wanted a friction fit, so they're not kind of loose and keep falling out. There we go. That one will go in properly sooner or later. There's his soon to be red eyes. I have to say, this is actually kind of freaky. I almost wish I hadn't started this. So I just soldered the 2 negative pins of the LEDs together and cut down the positive leads and that kind of 1 negative pin that I left sticking up, because this is what I really like, these kind of jumper cables. I bought a ton of these off eBay now. What you can do is actually plug that one in there, so that grey one is going to be negative, and plug those onto one of these onto each of the positives here. So that's made a pretty good connection with all those LEDs. Then all I need to do is just bend that whole lot down, and that end can plug into the breadboard. I just drilled that hole in the base and flattened out the metal again with a hammer. I'm just going to see if that's adequate to fit this this grommet in there. This is just going to protect the wire from getting damaged by the edge of the metal. So I got 2 grommets in the base, maybe not quite as neatly as I would have liked. In fact, that's not neat at all. These will do for the sensors. They seem to be just about the right diameter for the sensor wire. And all I need to do now is make sure that there's a good strain relief inside the box, just in case this wire gets tugged. That was kind of awkward. I actually didn't have any larger grommets than this one, so I had to cut one side of it open and kind of ease it into the hole while I'd got the thickest part of the wire past the hole. It's not as neat as I would have liked, but on the plus side I hardly need a strain relief on this part of the wire because that is tight in there. I'm almost ready to stick the breadboard in here now. I added this bracket which I flattened out in the vise as a strain relief. I've only got one sensor cable coming in at the moment, but once I solder it together the other sensor will come through that grommet there and also under the strain relief. As I said, this one doesn't need any strain relief because of the really thick bit on the cable here. This is where the eyes of the vampire are really coming in useful. I'm just calibrating the part of the program which tells if the earth is wet or dry in the pots. So I set the circuit up to turn on each eye of the vampire if the soil is too dry. So this probe is out of the earth at the moment. If I put it in the dry earth, the eye stays on, but if I put it in the wet earth, the eye goes off. Well, now it's gone off. And the same applies for the other probe. If I put it in the wet, both of the eyes go off. In the dry earth, the eye stays on. So that would correspond to the circuit, that is the program triggering the pump to turn on. So I'm just testing how the pump performs when it's at the bottom of this 5 litre water bottle. And what I've found so far is actually it's pumping too well. At that rate, this will have gone through the whole 5 litres pretty quick. So I think I need to adjust it so that the pump turns on for far less time. It's now set to turn on for 10 seconds at a time, but maybe I need to take that down to a far shorter interval. I just found another problem as well. I just found the pump has set up a siphon out of the bottle too, so I'm going to have to be careful to place the nozzle maybe on the same level or actually higher than the bottle itself when I set this up finally. This is the final part of the setup. I bought this thing called soaker hose at the local pound shop, and I've also placed this a lot higher above the pump than it was to avoid a siphon happening, and that seems to reduce the rate of water coming out. Now, of course, the main point with this is to spread the water across the whole tray of plants that I have over there, and the idea is that this should just gradually hydrate them and bring the soil to a state where the sensor turns off. So it's going to be a very gradual process, but with the kind of self-regulating sensor controlling the whole thing. I drilled some mounting holes in the back of the Vampire and screwed it to the window frame here. It would have made a lot more sense to drill the holes first because of course you don't really want little bits of metal flying around electronics, but I cleaned up all of the filings from the metal. Seems to be alright. The water bottle sits on the floor beneath the Vampire. I've already tested to make sure the pump is strong enough to pump the water up to the level of the plants. That first setup I tried with the soak hose didn't really work that well. I felt like having it down here in the plants was probably just going to damage the plants, and it didn't spread the water around very well. So I ended up cable tying the hose to this, I think it's basically a grill rack. This is basically just a grill rack like this one, which I cable tied some chopsticks to each of the corners to form legs, and then I cable tied the soak hose in a kind of crisscross pattern along the rack. I also poked a bunch more holes in the soak hose just with this needle file I had lying around, and that seems to have spread the water far more evenly over the plants. I also, because I raised the hose up, I noticed and also there's a far longer length of hose necessary to cover that entire area here. I had to raise the bottle up too, and that really helped the pump provide the pressure to push the water through. The system is actually turned on now, with the sensor attached down there, and it actually managed to turn itself off using the moisture sensor. So I'm hopeful this is kind of on the way to being a self-sustaining system. I suspect I'm going to have to tune it up over the next week before I go away, but this is looking far more promising. What I might do, because I have another bunch of plants here, I might create another smaller rack with another hose connected to the other pump and sensor that I built into here. So I hope you found that Arduino project useful, or at least interesting. It's a bit of a tutorial on moisture sensors, if nothing else. If you found that video interesting, please do subscribe, because I'm halfway through, well, a lot of the way through building this CNC machine over here, and that's what's been most of the content on my channel at the moment, and I hope to finish that pretty soon. So, and this is also an Arduino based system in the end. My laser cutter over there is also running an Arduino, which is kind of a necessary modification if you want to run a Chinese laser cutter with G-code. It's useful to know how to replace the electronics in there with an Arduino, and one of my most popular videos on my channel so far is based on how I converted this. So please like, subscribe if you want to see more Arduino projects, but especially if you want to see more kind of CNC tutorials as well. That is 3D printing, CNC router, laser cutters, etc. So thanks for watching, and goodbye. It's goodbye from me, it's goodbye from him.